Today we'll discuss about our next topic, milling operations. As you can see on your screen, we can perform different milling operations. The list is in front of you. The names are plane milling, face milling, side milling, straddle milling, angular milling, end milling, saw milling, form milling, helical milling, cam milling, thread milling, gear cutting, gang milling, milling keyways, grooves and slots. So we will discuss these operations one by one with the help of figures. First we will discuss about the plane milling. So plane milling, it is also known as slab milling or surface milling. You can see from the figure that there are two elements, workpiece and milling cutter. Milling cutter, with the tool which we used on the milling machine, is known as milling cutter. So in case of a plane milling, we are producing plane, flat, horizontal surfaces parallel to the axis of rotation of the plane milling cutter. Is called plane milling, surface milling or slab milling. So here is the axis of the milling cutter and we are producing plane flat surfaces, this one, parallel to the axis of rotation of the milling cutter. Next we will discuss about the face milling. In case of a face milling, we are producing or machining a flat surface which is at right angle to the axis of rotation of the milling cutter is called face milling. And the cutter used in this case is known as face milling cutter. Front of you for face milling. So this is the axis of this milling cutter and below it here is the workpiece. So in case of a face milling, the axis of the milling cutter is at right angle and the cutter is known as face milling cutter, this one. Next we will take the other type of milling, side milling. In this operation of milling, it is used for producing a flat vertical surface, this one, flat vertical surface on the side of the workpiece. This is your workpiece. By using a side milling cutter, this one is the side milling cutter. So we are producing this one, vertical surface, vertical flat surface, and this is the direction of the feed of the workpiece and the milling cutter is rotating clockwise. This one and this one. On both sides of the workpiece by using two sides and face milling cutters mounted on the same arbor. Arbor is same. We are using two side face milling cutter. First one is this one and second one is this one. Both the side and face milling cutters are mounted on the same arbor and the distance between the two milling cutters is adjusted by using spacing collars, as you can see from the figure. So we are producing such type of workpieces and this is very important, and this straddle milling is commonly used to produce square and hexagonal surfaces like nuts. This milling operation is used to machine a flat surface at an angle to the cutter axis. This one at an angle to the cutter axis other than at right angle as shown in the figure. This uses a single or double angle cutter depending upon the requirement. Like we are producing this type of surface, okay. So angular means angle other than right angle. In end milling, the cutter removes material with the help of teeth on its periphery as well as on its ends. Saw milling. It is the operation of producing a narrow slot or groove on the workpiece by using a saw milling cutter. The figure is in front of you. This is the saw milling cutter and this one is the workpiece. The saw milling can be performed for complete parting off, means we are dividing the workpiece into two different parts. The cutter and the workpieces are set in such a manner that the cutter is directly above the T slot of the table. This is the T slot of the table and the cutter is positioned just above the T slot. The cutter used in this case is called form milling cutter. Form F-O-R-M, form milling cutter, and it has the same profile or shape of its cutting teeth which is to be produced on the surface of the workpiece. So here is the workpiece which is fitted on the milling machine table, and this is the direction of the feed, and the cutter rotates about on its own axis, and the shape produced by the milling cutter, by the form milling cutter, is same which is desired on the workpiece. Helical milling. Helical means we want to produce a helical flute or grooves around the periphery of cylindrical or conical surfaces. This operation is carried out by swiveling the table to the required helix angle and then rotating and feeding the work against the rotary cutting edges of the milling cutter. Now next operation is cam milling. In cam milling, we are producing the disc type of cams, and the cams are basically produced on milling machine with the help of vertical head and dividing head fitted on the table. The dividing head is geared to the table lead screw, and the end mill is often used for cam milling. We are producing is to be same, so we take the help of universal dividing head and then indexing it, and this is the milling cutter. We will explain in the coming lectures in a great detail. Now next is very important, gang milling. Gang means A number of milling cutters are removing the material from the surface of the workpiece simultaneously, or you can say together. So here we are using when two milling cutters. First one is this one in the center, plain milling cutter, and two number of side milling cutters, this and this, are mounted on the same arbor, this one, and the space between the cutters is adjusted with the help of spacing collars. So we are removing material from the workpiece in this figure by three milling cutters. First one is the plain milling cutter in the center and the two side milling cutters. So this is known as gang milling. Ways, grooves and slots. So T slots, if we are using T slot cutter, this one, and we are producing a T slots on the workpiece, this is known as T slot milling. And if we are using groove milling cutter for producing grooves, this one, and slots milling. So depending upon the shape of the workpiece required, we are naming them. So milling keyways, grooves and slots. I hope you have understand the different milling operations. Thank you.